lines, a worker uses a surgical knife to meticulously carve out the cavities. He softens the rubber with paint thinner to enable precision cuts. Then he places a copy of the master in each cavity. Another disc goes on top. Then it's into a machine called a vulcanizer for 1 hour. This machine uses heat and pressure to cure the rubber, making it as hard as a car tire. It also melds the rubber around each master copy, embedding the detail. This will be the production molds for producing this pin design. Now, using a surgical knife again for precision, they carve out sprues, channels that during the casting process will direct the flow of molten metal to the cavities. They also make smaller, curved channels called runners to filter out any air or dirt particles. It's crucial to position the sprues and runners correctly because this mold produces an entire line of a particular pin. Mess up and they'd have to remake the mold from scratch. Next, they insert a centimeter-long brass tack called a post into each cavity. It'll later fasten to a clasp, attaching the pin to clothing. The post goes in now rather than later so that it will fuse to the back of the lapel pin during casting. Now to close the mold, they align the buttons on one half with the depressions in the other half. The mold then goes into what's called a spin casting machine. Using a cast iron ladle that can withstand the fiery temperature, they pour in molten metal, either pewter, zinc, or a tin alloy. As the machine spins, centrifugal force propels the metal into every nook and cranny of the cavities. After a minute of spinning, 400 rotations, the mold comes out. The metal takes about 5 minutes to cool and harden. The factory remelts the excess metal for the next batch. Next, a brass clasp called a clutch goes onto the post. Now the lapel pins go for an hour-long wash in soap and water and abrasive stones. The stones smooth out any rough edges. The pins go into the electroplating tank for a surface coating of metal. How many coats and the types of metal vary with the design. An electric current draws the metal particles onto the pins, plating them thoroughly. These pins first get copper plating, then nickel plating, then gold plating. Now it's time to paint the lapel pins. Workers follow a numerical guide like a paint-by-numbers kit. They paint each pin individually using minute quantities of epoxy paint. They control the paint syringe with a foot pedal. Once the paint dries, a machine called a pad printer gathers up ink and stamps on the tiny details, the ones too small to paint by hand. Pierce the post through the fabric, secure it with the clutch, and this lapel pin is now ready to wear. Like many inventions, the cardboard box was born by sheer accident. In the 1870s, an American printer by the name of Robert Gare stumbled upon the idea. By mistake, he cut a paper seed bag he was creasing with a metal ruler. Gare concluded he could create a sturdier container with paperboard. Now that was thinking outside the box. Cardboard boxes come in a wide variety of sizes, shapes, and colors, but most share three basic structural components. One wavy sheet of paper, called the flute, sandwiched between two flat sheets called liners. Together they form what's called a corrugated board. Production starts with a massive roll of partially recycled paper. The width of the paper varies depending on the size of the boxes they're making. The roll feeds a machine called a corrugator. The machine presses the paper between two ridged rollers and blasts it with hot steam. This shapes the waves of the flute. Another roller applies glue to one side of the flute. The glue's main ingredients are water and starch, which won't contaminate fresh produce the boxes may later contain. Next, the machine adheres one liner sheet and then the other. The waves create an air cushion between the flute and the liners, strengthening the board. For added strength, some boxes have a double lining, 2 flutes and 3 liners. The flutes may also vary in thickness for more or less cushioning. The factory uses partially recycled paper for the flutes because it's more malleable than non-recycled paper. A razor-thin circular saw trims each side. The corrugator machine then cuts the board up to 9 times, depending on the size of the box they're producing. The corrugator's final function is to separate the boards into layers using flexible aluminum tongs called fingers. Workers do a quality control check before sending the boards off for printing. The next machine stacks the boards into piles of between 25 and 80, depending on their thickness. This machine also feeds one board at a time to the upcoming equipment. It does this at lightning speed, at a rate of up to 8,000 boards per hour. First, a trimmer perforates the boards to create flaps and handles. Rubber sponges cushion the blades so that they cut only the parts they're supposed to. During the trimming, a press condenses the box's overlapping panels to level out their thickness. Workers usually cut the sponges by hand to make sure they fit snugly around the blades. The trimmer runs at a speed of 8 kilometers an hour, processing up to 90 boxes per minute. Workers send the cut-offs back to the paper mill to be recycled as many as 6 times over. A folding machine now bends them along score lines the corrugator made earlier. It then applies cold glue to the sections that'll join together